For objective 9, it's similar to the first objective where we have fewer questions on the actual test. So for objective 8, there were 4 questions. For objective 9, there's only 2, but we've got 3 of these to look at. And the first problem is pretty basic because it's just asking if this point xy is a solution to the system below. So we just need to check if it works for both equations. So if I have 2 times the x value, which is 7, minus the y value, which is 6, equal to 8, we want to see if that's true. So 14 minus 6, yes, that is 8. But it only works for one of the equations. We need to check if it's true for the other. So for the other, we've got y, which is 6. Is that equal to 7 squared minus 2 times 7 minus 13? Well, if we do that, we will get 49 minus 14 minus 13, which is 22. And I know that 22 is not the same as 6. So therefore, because it's not true for both of the inequalities, 6 is not a solution to the system. For the second one, I'm going to show both methods, solving by substitution and elimination. We're going to start with substitution. I always look for the variable that has no coefficient. So I see a 5, I see a 2, I see a 3, but I just see a 1 for this one. So that's a clue that I want to isolate the y here, which means I need to subtract 3x from both sides to get the y equal to negative 3x plus 5. Once I have that, I can substitute that expression in for y in the first equation. I have 5x plus 2 times negative 3x plus 5 equal to 7. Distributing the 2 to both terms, I get 5x minus 6x plus 10 is equal to 7. I can combine these together and subtract the 10 from both sides to get the negative x is equal to negative 3. We can swap both signs by dividing by negative 1 on both sides and getting positive 3 for x. Now I need to figure out what my y value is. Well, I have that equation up there. Y is equal to negative 3x, which is 3, plus 5, which is going to be a negative 4. So our x value is 3, y value is negative 4 as our final solution. So that was solving by substitution. Now to look at elimination. So with elimination, we are trying to make both of the variables have the same coefficient. So the simplest one I see is making this into a 2. I can't just sneak a 2 in there, though. I have to multiply the whole equation, both sides, by 2. So I get 5x plus 2y is equal to 7, and then 6x plus 2y is equal to 10. A good strategy to use is to multiply by negative 2, or you could just subtract down. Be very cautious of it, though, to make sure that you are, in fact, subtracting the top minus the bottom each time, because that's usually where the mistakes come in. But when we do 2y minus 2y, those will cancel. 7 minus 10 is negative 3, and look at that, we're back at where we were before, dividing by the negative 1 to get x is positive 3. Then we can substitute that into either of the two equations. I usually just do the top one, so 5 times x plus 2y is equal to 7. So that's 15 plus 2y is equal to 7. Subtracting the 15, I get 2y is equal to negative 8. And so dividing by the 2, I get negative 4 for my y. So I've got my x, I've got my y, and look at that. It's the exact same solution as the last one. And for this last problem, I've got the y already isolated, so I can just substitute this in for y in the top equation. Absolutely, you need those parentheses because we need to distribute that negative sign to all of the terms. It's not plus 13 is equal to 8. So that negative 1 is distributed to all the terms. We get 2x minus x squared plus 2x plus 13 is equal to 8. And I like to keep my a value positive, so that's a negative sign right there. So I'm going to move all of these terms to the other side. So minus 2x minus 13, so minus 2x plus x squared. I get a 0 on one side, all of those cancel. I'm going to rewrite this in the proper order. So it looks like I've got two negative 2x's, which is negative 4x, and then negative 13 plus 8 is negative 5, a little box diamond on that. And I get my negative 5 on top, negative 4 on the bottom. That's negative 5 and 1. So that's negative 5 down there with the x squared up there, x minus 5, x plus 1. X plus 1. So my two solutions are positive 5 and negative 1. But it's not just the x's I'm looking at, I'm also looking for the y's. Now we can choose either of these two equations, but I tell you the most mistakes happen when students use the bottom equation because it's a quadratic. So I would use the top equation even though it's not written out right. But I can take some time and rewrite that. Let's see, 2x minus y is equal to 8. I would add the y. You can absolutely subtract the 2x and then divide by -1, but that's usually where mistakes can happen. So either of the two methods do work. Equal to y plus 8, then I can move that 8 over. So I get 2x minus 8 is equal to y. Then I can substitute in the 5, 8, and so that's going to be 10 minus 8, or 2. So when I substituted in 5, I got 2. And then for the other one, 2 times -1 minus 8 is -2 minus 8, or -10. So when I substituted in -1, I got -10. So these are your two solutions, the 2 points where they intersect. Oh, yep. That's the end of that objective. So on the other video, you'll be